Hi, I want to talk about an application of kinematics, using kinematic data as a way of making a measurement. And an example of this comes towards the end of The Lord of the Rings, The Fellowship of the Ring. So as the Fellowship is going through the Mines of Moria, Pippin gets bored, sees some stones near the top of a well, and drops the stones down the well, waking the sleeping Balrog, triggering the epic fight between Gandalf the Grey and the Balrog, leading to Gandalf's reemergence as Gandalf the White. All of that, though, is totally irrelevant to the physics. The physical side of it is, we could use information from that fall to figure out how deep that mine shaft happened to be. So, for example, if we heard the sound from that stone landing 7.5 seconds later, we could use the fact that the stone started at rest, fell for 7.5 seconds, and calculate the depth of the well. So, in freefall, Middle-earth is Earth just a little bit earlier in time. So the acceleration would be minus the strength of gravity, which we approximate as 9.8 meters per second squared. We're starting at rest. Our change in time is 7.5 seconds, which means we don't know our distance and we don't know our final velocity. But we don't need to know how fast that stone was traveling just before it hit the bottom to figure out how far it fell. So, using the equation of motion without our final velocity, our change in y is going to be equal to our initial speed times time plus 1/2 times our acceleration times time squared. Well, our initial speed is 0, so from our simple model here, 1/2 times negative 9.8 meters per second squared times our time of 7.5 seconds squared is going to give us a change in y of negative 275.6 meters. So the well would be negative 280 meters. The end. Maybe. Remember, we're getting this data back from sound traveling upward. So in part 2, I'll talk about how we could incorporate that fact, because all information that we receive technically comes from the past, because all information travels at the speed of the wave carrier that is carrying that information. So in part 2, we'll solve this a bit more properly to get a better estimate of the depth of that well. Thanks for watching part 1.